Welcome everyone. In this video, we're going to discuss integration by parts. That's one of the technique of integration. We're going to discuss the tabular method, which is a shortcut to the integration by parts. When you use integration by parts more than once, you might want to use this method rather going through integration by parts. Here's the idea. So we know the integration by parts gives us this formula. If you're integrating u dv, then this is u times v minus the integral of v du. So this is the formula we know from integration by parts. Now say we don't want to use the formula, we want to use the quick method. That's what I'm going to illustrate to you here. So let's consider an example. So say we want to integrate the following. We're looking at, say, x cosine of x dx. So if you're integrating this function, it's a product of two functions. So we know integration by parts will be the way to go. So to use the shortcut, here's what you're going to do. You're going to create two columns. So you make a table like this. So in the first column, we're going to be differentiating. So let's put d over dx. The second column, we're going to be integrating. So let's put the integral symbol and dx. So often we choose what to differentiate, what to integrate from our given problem. So I'm going to choose this one to be differentiated. So I put it right here. And I'm going to pick this column to integrate. So let's put cosine of x here. Now let's continue. So this column right here, you're going to differentiate until you get 0. Even if you don't get 0, you can continue to some level, but it works nicely when the derivative eventually goes to 0. So if I differentiate once, x, I get 1. If I differentiate again, I get 0 because derivative of a constant is 0. So I have finished differentiating my differentiation column. Now I integrate. So I integrate cosine. Derivative integration of cosine is going to be sine. So we know sine is the integral of cosine because derivative of sine is cosine. Then you integrate again, you get negative cosine because the derivative of cosine is negative sine, so that negative and this negative cancel out. So you can always backtrack. So once you get to the 0th level, you stop integrating. That's why it's important to get 0 for the differentiation column. Now here's what you're going to do. You pretty much take your first column right here and multiply with the second component in the second column. And you cross them like this. And then you go to the next one, you go diagonally and multiply them like this. And of course, we stop at 0 because 0 times whatever came after is going to be 0. That's why we stop at 0. Now, as you're multiplying them diagonally like this, you also multiply them with the +1 minus 1. So +1 here, -1 here, and then plus, minus, and so forth. You start alternating them. So we pretty much have our answer. So this integral is equal to x times sine of x minus 1 times negative cosine of x, and of course plus c of the integration constant. Now here we're going to clear out these negatives, so our final answer is going to be negative times negative, so that's positive cosine of x plus c. So that will be our final answer to this problem. Let's go ahead and try another one. So let's try to use this method for the following. So say you want to integrate x cubed times e to the 2x dx. So this you definitely want to use tabular method because if you use by parts, you might end up integrating more than once. And it could be tedious to do that. So we're going to go ahead and set up our table. So here's our table. So the first column, we're going to differentiate respect to x. Second column, we're going to integrate respect to x. So I just put their symbols. So I'm going to pick this one to be the function I'm going to differentiate. So let's put x cubed here. The reason I choose that because eventually it's going to go to 0. And the second, that means the remaining piece are the function we're going to integrate. So this would be e to the 2x. All right, so let's fill in the table. So when I differentiate x cubed, I get 3x squared When I differentiate 3x squared, I get 6x. When I differentiate 6x, I get 6. Differentiate 6, you get 0. All right, so that's where we stop. Once we get to 0, it's good. And now the second column, we're going to integrate. So we're doing integral of e to the 2x. So here you can think of using a substitution. This is really e to the 2x divided by 2, or times 1/2 plus c. So keep doing that. So this will be e to the 2x times 1/2. And then if I integrate that again, I get 1/4 e to the 2x, and then 1/8 e to the 2x, and then 1/16 e to the 2x. So that's where the integration column, again, when you get to the 0th level, you stop. And now we cross them like this. So this times that, so first with the second and plus sign, then this with that, and we're going to alternate minus sign, this one with that one. So it's going to be a plus sign, and then the last one, this one with that one, it's going to be a minus sign. All right, so let's write out the answer. So our answer to this integral, it's going to be the product of x cubed times 1/2 e to the x, positive, so x cubed over 2. So let's write it this way. 1/2 x cubed e to the 2x, and then minus 3x squared times 1/4 e to the 2x. So this is 3/4 e to the 2x. And the third one, I have positive 6x times 1/8, so over 8 e to the 2x, and then minus 6/16 e to the 2x and plus c. So that's the final answer. Now, if you want, you can simplify these coefficients so that it looks better. So I'm going to go ahead and rewrite the answer. So 1/2 x cubed e to the 2x, 3/4, that doesn't simplify. So minus 3/4 x squared times e to the 2x. And then plus, now 6 and 8, I can simplify them. So this will be plus 3/4 x e to the 2x. And the last one, 16 and 6. So that's going to be 3/8 e to the 2x plus c. So that will be our final answer for this problem. Right, so I hope you enjoy this quick method for integration by parts. Take care.